Bismillahirrahmanirrahim. Electrical conductivity is a fundamental property of electronic and electrical material that indicate how well they can conduct electrical current. It varies significantly among different classes of electronic materials, which can be used to broadly classify the materials itself into four categories, such as conductors, semiconductors, insulators, and even superconductors. Conductors are such electronic material that allows the flow of electric current with minimum resistance. And a conductor generally have very high conductivity, approximately greater than 10 power 6 Siemens per meter. And in conductors, electrons are free to move and they have a large number of free charge carriers. Examples of conductors are metals like copper, aluminium, and gold. And electronic material have a lot of application of conductors, such used for the electrical and electronic wiring in the circuits, and ohmic component of ICs and contact of VLSI, ULSI, and even MOSFET, CMOS, transistor diodes. They are all different application of the conductor in electronic materials. Another classification of electronic material is semiconductors. And these materials have intermediate conductivity between conductor and insulator. And semiconductor generally have moderate conductivity, typically in the range of 10 power minus 6 to 10 power 6 Siemens per meter, which can be manipulated or adjusted by doping or by changing the temperature. The conductivity in semiconductor increases with the temperature or impurity. There are many examples of semiconductors which are used in electronic devices and VLSI, ULSI circuit, such as silicon, germanium, gallium arsenide, and recently organic and polymer semiconductors. In other words, semiconductors are the backbone of modern electronic devices, and they are widely used in electronics, including diode, transistors, and solar cells, and nearly all electronic devices. They are fundamentally used. Another classification of electronic material on the basis of electrical conductivity is insulator. Insulators are such electronic material that do not conduct electricity well, and insulators have very low conductivity, typically less than 10 power minus 6 Siemens per meter. And in insulators, electrons are tightly bounded to their atom and making it difficult for them to move freely under the application of the applied voltage or even temperature. There are many examples like rubber, glass, and most ceramics material. And insulators have many applications in electronic devices, and they are generally used to prevent unwanted flow of electricity, such as in electrical insulation and protective coating for ICs, and they are especially for the MOSFET. Another classification for electronic material on the basis of electrical conductivity is superconductors. Superconductors are a special class of material that exhibit zero electrical resistance below a certain critical temperature. Superconductors have infinite conductivity, generally below than critical temperatures, and they can expel magnetic field, which is generally referred as a Meissner effect. The Meissner effect is the phenomenon for which a superconductor expels all magnetic fields from its interior when cooled below its critical temperature, and causing it to exhibit perfect diamagnetism. Examples of superconductor materials are niobium, lead, and certain ceramics materials. The superconducting temperature of niobium is approximately 9.25 Kelvin, which is minus 263.15 degrees centigrade. This is known as the critical temperature for niobium, and below which it exhibits superconductivity. The superconducting temperature of another superconducting material, lead, is approximately 7.2 Kelvin, which is close to minus 265.95 degrees centigrade. Below this temperature, lead exhibits some superconductivity. Superconducting materials have very common application for electronic devices, particularly used in MRI machines, particle accelerators, and magnetic levitation systems. Superconductors are integral part of to the operation and development of superconducting qubits for quantum computers. They are recently developed and forming a key foundation for advancing quantum computing technologies.